This work is about analysis of shrubby arborean species as a barrier to wind for comfort in open spaces. We made microclimate studies of wind velocity attenuation for thermal comfort in open spaces using plants as wind barriers, and this empirical data will serve to subsidies for our studies. We are looking for innovative correlation between vegetation and the leaf area index. We have positive trends and it's an accessible measurement index, and we can export to other species. This is an empirical research with complex studies, so we are looking for parameters. Some studies about plant barriers made relationships between the barrier shelter capacity and its porosity, with different heights and shapes and different positions in relation to the incident winds. Some results are: the larger and denser the vegetation, the greater the barrier effect. Density is an important feature in the effectiveness of the whole shelter belt, and an average porosity is more efficient. These experiments are part of current studies, and it's detailed in the bibliographic review of the author's master's thesis. The study area is the IPT campus in São Paulo, Brazil. This is located next to the São Paulo University. This is the study area a little closer. And this is the ETSAC campus with the shrub tree species located. We had 42 pre-selected plant samples and 16 species was chosen for effective measurements. The choice criteria was variety of available species, different densities of the crown composition, representative shrub tree species, elements with a crown at the height of pedestrians, and favorite location for measurements. These studies were carried out in the summer period when the species are most vigorous, because the main objective of this research stage was to divide the species into ranges of different leaf area index values, seeking a correlation with the wind barrier effect. Subsequent measurements on species in the winter period will be adequate. All measurements were made from 8:30 a.m. to 4:30 p.m., 1 day per species, between January and February 2019, and recorded every 5 minutes, and measured by a Campbell scientific station with a data logger and a serial collector for battery power, and connected to 2 sets of equal data collectors, one of each side of plant barrier, and each set containing 1 thermohygrometer and 1 sonic anemometer. In this study, the most relevant is not the intensity of the wind itself, but how much were attenuated by the barrier. So, in case of wind direction inversion, the values were also inverted in such a way that it's all considered the relation from the highest to the lowest intensity of incident winds. The data collectors were placed in tripods at a height of 1.50 meters near the plant barrier at 2 opposite points. In the table 1, we have the plant species and wind attenuation results. In A, we have the total measurements in all wind incident directions. In B, we have the results in the 8:30 a.m. to 4:30 p.m. period, also in all wind incident directions. In C, we have the results in the same period, but only considering the normal wind incident direction. The results obtained were divided into four classification ranges for future comparison with the leaf area index to be measured looking for the correlation. The results obtained in B were adopted as a pattern because of the similar conditions to those obtained in the relevant bibliography, and it's measuring free incidence of winds and not just the normal incidence. And in this case, we have the ranges are adjusted to 33 to 39%, 40 to 45, 46 to 49, and 50 to 54%. The results listed in C, only considering the normal wind incidence direction, will be used for specific purposes in the research in progress. In this situation, the wind attenuation results even 14% higher than the B considerations, and this result is expected since only the incidence of winds that effectively cross the vegetation is considered. The following graph shows the attenuation percentages listed in A, B, and C conditions in the 16 measures vegetable species. And here, the results of attenuation. The results indicate that the chosen species are representative for the continuity of wind barrier studies and the possibility of obtaining the desired correlation. Additional measurements are planned to increase and validate the data obtained so far, and will be carried out concomitantly to the measurements of the leaf area index species, as well as tests on wind tunnel to improve and validate the obtained results. We would like to thank the FAUSP for the support and loan the measuring equipment, and we are also grateful for the important support of the EPT in allowing measurements on its campus, making this research feasible. And here we have the references. Thank you.